Hello students, welcome you to this session. So last class finally we studied local maxima, local minima using second derivative, right? So hope you are remembering the conditions for both local maxima and local minima. The first condition remains same, right? You find dy by dx equals 0. Then you find second derivative d square y by dx square. If it is positive, we say there is a local minimum. If it is negative, we say there is a local maximum. Okay, so that's a very simple thing. So in today's class, I'm going to teach some of the applications of maxima, minima, some statement sums, very important. Only thing, you frame the equation. Once you get a function, function of x. But remember, function of x means only x must be there. You should not have any other letter, right? Single variable, function of x or function of t or function of a, function of y, whatever it is. But it must be a function of a single variable, okay? So you should not have 2-3 variables here. So convert it into a single variable, that's very important. Then you differentiate two times, f dash x and f double dash x. Then usual method, equate first derivative with 0, you will get stationary point. Then at that point, there is either a maximum or minimum, local maximum or local minimum. To identify, you substitute in the second derivative. If it is positive, local minimum, negative, local maximum. Let's move on to some of the questions. First, I'm going to take example 7.61. Look at this one. Find the local maximum and minimum of the function. A function is given. But see the given function. Given function is x square into y square. You can't take it as f of x, right? Because we have x and y. You convert it into a single variable, either x alone or y alone. Then only you can take it as a function of x or function of y. For that, you can make use of another equation is given, no? The line x plus y equal to 10. From that you find any one letter. Either you find x value or y value. I am finding y from here. What is y here? 10 minus x. Take it as equation number 1. Substitute in the function. So x square into y square. Instead of y you write 10 minus x. Now we have only x. So you can name it as f of x. Are you able to understand? So a function given in which we have x and y, two variables. We want to convert it into a single variable. For that you make use of the next condition, x plus y equal to 10. From that you find y value. That y value substitute here. Now we are getting a function of x alone. Now you know how to do that. You have to differentiate two times. But for that, better, you just expand it, make it as a polynomial equation. So f of x equal to x square into, this is a minus b the whole square. So a square minus 2ab plus b square. Then multiply everything by that outside term x square, right? So f of x equal to 100x square minus 20x cube plus x raised to 4. If you want to arrange in order, not compulsory. X raised to 4 minus 20x cube plus 100x square. Now we got the function. Now what we studied last class, right? So now you differentiate two times, right? So you find f dash x, x raised to 4 derivative 4x cube minus 60x square plus 200x, right? Again, once again you differentiate f2 dash x. 4x cube derivative 12x square minus 120x plus 200, right? This is f dash x, f double dash x. Now, for maxima, local minima, first you have to find stationary points, right? For that, the condition is first derivative 0. Equate the first derivative with 0. So what is first derivative here? 4x cube minus 60x square plus 200x equal to 0. Now it is an equation. So 4 is common. If you want, you can divide. Don't divide x. If you divide x, you'll be losing 1 point, right? So x equals 0 is one of the solution. So I'm taking 4x outside. If I take 4x common, you will get x square minus 15x plus 50 is equal to 0. There are two possibilities. Either 4x equal to 0, or you do one thing, you can factorize it. 4x into sum is minus 15, product is 50 minus 5 and minus 10. So x minus 5 into x minus 10 equal to 0. So you are getting three values you are getting. One value x equals 0 because 4x equals 0 means x equals 0. X minus 5 0 means x is equal to 5 plus 5. X minus 10 0, so x is equal to plus 10. These are the three stationary points. At these points there is a local maximum or minimum. So you take one by one. We take the first point. What's the first point? X equal to 0. When x equal to 0, how can you identify local maximum or minimum? You substitute in the second derivative. You find f2 dash of x. What is f2 dash of x? 12x square minus 120x plus 200, in which wherever x comes you put 0, right? So the first term 0, second term 0, only 200 you are getting, right? So you are getting 200. It is positive. Second derivative positive, just opposite you should say, right? Second derivative positive, local minimum. Therefore, there is a local minimum at x equal to 0 and minimum value is substitute that point in the given function. In f of x you substitute, right? So f of 0. So what is f of 0? That's very easy calculation, right? So this is our f of x. Even here you can substitute x, you put 0, 0 square, 0, 0 in anything, it is what? 0, right? So f of 0, so the answer is 0. So that is the answer for the first part. Now take the second stationary point. What is that? X equal to 5. So same method, you take the second one. When x equal to 5, we have to identify whether there is a local maximum or local minimum. For that you substitute it in the second derivative, f2 dash of x. What is f2 dash of x? 12x square minus 120x. 12 into 5 square, 25, minus 120 into 5 plus 200. So when you simplify, you will be getting minus 100. The multiplication, addition, subtraction, I am leaving it to you. You will get minus 100. It is negative, right? So negative, second derivative negative. So we say there is a local maximum, just opposite. When it is negative, maximum. Positive, minimum, right? Therefore, there is a local maximum at x equal to 5. And the maximum value is, substitute this x equal to 5 in the given function, f of 5. What is f of 5? Listen. For x you put 5, so 5 square, 25, it is 25 into equal to x square, 25 into 10 minus x, right? 10 minus x you are giving 5, so 10 minus 5, 5, so 5 square is 25, right? So 25 into 25 you are getting, so 625 is the maximum values. Don't stop, still one more point, right? What's the next point? X equal to 10. So when x equal to 10, you substitute in the second derivative f2 dash of x is. For x you put 10 in the second derivative. See, this is second derivative. X you give 10. So 12 into 10 square minus 120 into 10 plus 200, right? 12 into 10 square. 12 into 10 square, 100 minus 120 into 10 plus 200. Okay, so 12 into 100, 1200. 120 into 10 also 1200. One is plus, one is minus, both get cancelled. You are getting 200 positive, right? Positive means what you say? Local minimum. Therefore, there is a local minimum at x equal to 10. And the minimum value is f of 10. Minimum value is f of 10. So what do you do? In the given function you put 10. Very simple. X you are giving 10. So 10 minus 10 is what? 0. 0 square. 0, 0 in anything. It is 0. So here also you are getting the answer as what? 0. So hope you understood this. So this is the basic thing you need for to do the next few questions. Okay. So application sum just I recalled, right? what is local maximum, what is local minimum, right? Then the working procedure, a function of single variable you should convert. That's more important, right? Okay, now let's move on to that exercise.